So here's here's the next video with the word problems. I posted this on a video, download it, and then you can work the problems with me. I'm going to do some of them in this video and some of them in the next video. So the first ones here will be the area problems that I'll do, mostly. Anyway, alright, so the first one, it says 550 feet of fencing is available to enclose a rectangular yard alongside the Genesee River, which is one side of the rectangle. What are the dimensions of the rectangular yard, and what is the maximum area that can be enclosed? Alright, so I drew a very sad little picture with my river flowing to the right and my rectangular yard next to it. So if I were doing this, I would probably put an X and an X and a Y or an L. Maybe I won't do that. Maybe I'll do W's. W, W, and L for length. So I know that length plus 2W has to add up to my 550 feet. Okay? Now, I don't really want to have two variables. It's too messy, so I'm going to solve for one of the variables. Since L is already by itself, I'm going to subtract 2W, and I'm going to have L is equal to 550 minus 2W. Alright, so now I want to maximize the area. So whatever you're going to maximize, that's the formula you need to write. So I know that area of a rectangle is length times width. So that's my 550 minus 2W times my W. That's my area. So distributing my W, I have 550 W minus 2W squared. I want to maximize, so remember, because if I look here, my A is negative 2W squared, so it means my parabola is an upside down area parabola. So the vertex is going to be a maximum, so I want to find where does that vertex happen. So my axis osymmetry from the previous video is x equals negative b over 2a. Well, in this instance, it's w is in place of x, and negative b is negative 550 divided by 2 times negative 2. So 550 divided by 4 is 137.5, says my notes, 137.5. So that's the width of my rectangular yard. So my length is 550 minus twice that, 137.5. So my length is 275. Okay, so those are my dimensions. So writing it over here, I'm just going to write that the width is 137.5 feet, and my length, because these are the dimensions, is 275 feet. So those are my dimensions. And then the other thing I want is the maximum area. Well, area is going to be length times width. So 137.5 times 275 is going to be a really large number. It is 37,812.5, and this is square feet. That's why the number is so huge, because square feet are pretty small when you're talking about areas for some sort of fenced-in thing. So that's my maximum area. I'll just write max area. That was horrible. Max area. And so that's the other thing that I was looking for. So as you do these problems, the next one is exactly the same, so I'm not going to do it If you want to look at that again when you have a chance, but you might want to try it. I could tell you that the dimensions are 425 feet by 212.5, and then the maximum area is 90,312.5 square feet. So if you wanted to do that one on your own, there's the answer. If I look at the next one, it's this time my rectangular yard is going to be divided in half. So I already drew the picture ahead of time. So I'm going to call this my W, and now I have 3 of them, and I'm going to call this whole thing my length, which I have 2 of them. So now I have 2L plus 3W is equal to whatever my fencing is, which is 2,050. So 2,050. All right, so now the question is, should we solve for L or should we solve for W? Well, personally, I don't really want to divide by 3 because 2,050 doesn't divide by 3. So I'm going to subtract 3W and solve for L. You can choose either one, it doesn't make any difference. So 2L is equal to 250 minus 3W divided by 2. So I get L is equal to 1025 minus, if you want to make that a decimal you can, because it's a nice decimal, or if you want to leave it 3 halves you can do that also. I'm just going to write 1.5 W just because. So now again I want to, it says maximize the area, so I'm going to do area again just like I did before. Area is length times width. So my length is my 1025 minus 1.5 W, and my width is just width. So I get 1025 W minus 1.5 W squared. All right, and I want to maximize my area. Notice again that the A value is negative, so we can do our axis asymmetry, which is X, which is in this case W, equals negative B over 2A. So that would be negative 1025 divided by 2 times negative 1.5. And so in this case, X or W is equal to 341 and 2/3. 341 and 2/3 feet. So I'm going to leave it 2/3 just because. So my length then is 1,025. What was that? 1,025 minus 1.5 W times 341 and 2/3. And so according to my notes, my length is 512.5. So my dimensions, my width back here, which is X. So my width is 341 and 2/3 feet, and my length is 512.5 feet. So the width is 341 and 2/3 feet, and my length is 512.5 or 0.5 feet. Those are my dimensions. Oops, sorry. These are my dimensions. And what's the maximum area? Well, they didn't even really want the dimensions, did they? So now I'm just going to multiply. So my max area is 341 and 2/3 times 512.5, which gives me an answer of, let's see, according to my notes, 175,104 square feet. And that's the maximum area that I can enclose. Farmers like these things. All right, so those are my two area problems. I'll leave this up here for a minute